Alright guys, let's go ahead and finish up 6.2b. So let me go ahead and bring up the lesson really quickly, and we'll go ahead and finish this. Remember, when we finish with the lesson, I want you guys to go ahead and start your homework. That way, when we get the quicker you get started, you guys can finish the homework and not have any homework over spring break. So let's go ahead and see where we laid off. We did that one. Okay, so it says, for the right triangles with the side lengths a, b, and c, if a squared plus b squared equals c squared, then the triangle is a right triangle. This is converse of the Pythagorean theorem. So what this is basically saying is I have these three side lengths. And what I want you guys to do is first tell me which side would be the hypotenuse. Now, as we talked about, the hypotenuse is always the longest side. Then once we do that, I want you to make sure that these are right triangles by doing the Pythagorean theorem. So what do I mean by that? First, what I'm going to do is on A, look at which one would be the longest side. Obviously, this one, 61, is the biggest number, so therefore that would be my biggest side. So if I plug these in now to Pythagorean theorem, which would be a squared plus b squared equals c squared, this would be my A, this would be my B, and this would be my C. So it would look like 11 to the second power plus 60 to the second power needs to equal to 61 to the second power. Now, if this is true, that means this would be a right triangle. If, when I solve this, it does not equal each other, this is not a right triangle. So 11 times 11 is 121. 60 times 60 is 3,600. And 61 to the second power is 3721. Now when I add these two together, this side also equals 3,721, which equals 3,721. This is a true statement, so therefore this is a right triangle. Okay, so now let's move on to the next one. When it looks like this, it's a little trickier, but if you guys remember to the last video lesson I gave you, I believe it was like 3.1D, it was zooming in and finding the values of irrational numbers. What we can do is see which one of these are biggest by squaring each of these numbers. This would be 65, this would be 81, and this would be 15. So looking at this, we can tell that the largest number is 9. So this, if it's a right triangle, would be my hypotenuse. So let's go ahead and see if it is. When I plug these in, I'm going to have the square root of 65 squared plus the square root of 15 squared is going to equal to 9 squared. Like we just did, this would be 65 plus 15 equals 81. This would give me 90 equals... Excuse me, that would not give me 90. That would give me 80 equals 81. So as you guys can tell, 80 does not equal 81. Therefore, these side lengths, when connected, they would make a triangle, but they would not make a right triangle. All right, so let's go and look at this one now. Similar, if I were to square all these values, this would give me 16. This would give me 4 times 5, which is 20. And this would give me 4. Okay, so now looking at that, I know that this is my C value. So it would look like 2 to the second power plus 4 to the second power is equal to 2 radical 5 to the second power. This would then give me 4 plus 16 is equal to 20, which I just did right on over here. And I would get 20 equals 20. Therefore, this one is true. It is a right triangle. Now, this last one's a little tricky because I got decimals here. So what I would do, one more time, I would square all these numbers and just see which one's the biggest. This is 7. 3.2 to the second power is 10.24. And 1.8 is obviously smaller than 3.2. So, but just so you know, when I take that to the second power, that is 3.24. So now when I look at all these values, this is going to be my C. So I'm going to have radical 7 to the second power plus 1.8 to the second power. It's going to equal to 3.2 to the second power. This would be 7 plus 3.24, which needs to equal 10.24. And when I add these up, I do get 10.24 equals 10.24. Therefore, this is also a right triangle. So the only one that's not a right triangle is this one. False, not a right triangle. All right, so looking at this next one, what we are going to do is we're going to look at this person and see what the mistake they made. So here's the triangle, and they saw, okay, I have a 5 and I have a 13. I'm going to plug these in to a squared plus b squared equals c squared. And I want you to notice what they plugged in. They said this was my a, which is fine, but then they said this is my b. As I showed in the previous video, whatever side is across from the 90-degree angle is my c value. They just chose that as my b value. So the correct way to look at this then should have been 5 squared plus b squared is equal to 13 squared. This would have been 25 plus b squared is equal to 169. And then when I minus 25 on both sides, I'm going to get b squared is equal to 144. And if we take the square root of 144, that is a perfect square. So we're going to get b equals 12. So the mistake you would say is they plugged in 13 for the b value instead of the c value. All right, guys, let's go and look at this one. This one is difficult to visualize on your paper, so I try to color code it the best I can. So what I want you guys to realize is that they have a rectangle, and they have this red line going from this top corner going down across to this corner. Okay, so if you know the classrooms of the school, it's basically saying, hey, this is Mr. Jenkins' classroom in the B building. This line is going all the way to Nibo's classroom, which is down across from Willis. Okay, so hopefully that visually helps you guys see that. And what I want you guys to do is I want you to figure out what is this diagonal length. So what we need to do is create a right triangle. I have this red value going down, and I need a value going across from this corner to this corner. So I'm going to go ahead and draw that right now, and I'm going to use this light blue color to illustrate that. This is the value I need to find because I need to use that in order to find this right triangle. So that is the right triangle that I'm trying to use. So I drew this light blue line. So you guys should go ahead and do that too. And I want you to notice now, I'm going to use orange to illustrate. I have a second right triangle here. So if I pulled out this right triangle, the C value I do not know, the one going from corner to corner that I drew in the light blue, this would be 6 and this would be 10. So therefore now if I plug this in the Pythagorean theorem, I would have 6 squared plus 10 squared equals c squared. This would be 36 plus 100 equals c squared. So therefore 136 equals c squared. And if I took the square root of both sides, I would have c squared equals the square root, I would have c equals the square root of 136. Now you could break this down a little bit more to figure out what the values are, but it actually helps me out if I just leave it in square root of 136, because I'm going to do a little bit more math later or next, and it's just quicker to leave it. Now what I'm going to do is I want to find this red value, so I'm going to pull out this rectangle. I am trying to figure out this diagonal. This height corresponds with this side, which is 15. And this light blue side, which I just solved for, is the square root of 136. So now what I'm going to do is plug this into the Pythagorean theorem. And this is going to be the square root of 136 to the second power plus 15 to the second power equals x. Now hopefully this shows you why I did not simplify this out or make it simplify the radical, because these just cancel and I get 136 plus 225 equals x. Now when I add 136 plus 225, I'm going to get 361. And that's going to equal x squared. So now I'm going to take the square root of both sides, and I'm going to get x is equal to 19. So therefore, this red length going from corner to corner is 19. All right, so what we need to do on this next one, it says, for the right angle triangle, give 3 possible combinations of the leg lengths so that the leg lengths are integers and that the x is an irrational number. So basically what it's saying is I'm going to do a squared plus b squared equals c squared. And I want these to be nice, pretty numbers here. I want them to be like 1, 2, 3, 4, 5, so on and so forth for both of these. I want c to be a number that is going to be an irrational number, so not a perfect square. And I want that number to be between 5 and 7. So the square root of 25 is 5 and the square root of 49 is 7. Therefore, when I add up a squared and b squared, I want that number, I want my leg lengths, when I add them up together, I want them to be greater than radical 25, but I wanted them to be less than 49. So let's go and look at a few examples of these. If my leg lengths were 3 and let's say 5, okay? And that means I need my hypotenuse to be an irrational number. Well, if I square these numbers, I'm going to get 9 plus 25, which equals 34 equals c squared. If I take the square root of both of these sides, that would give me c equals radical 34, which is between 49 and 25. So the three side lengths could be 3 and 5. All right, so now I'm going to clean some of this up. And let's go and choose some other numbers. So let's say I did 4 and 4. This would look like 4 squared plus 4 squared equals c squared. This would give me 16 plus 16 equals c squared, which would be 32 equals c squared. When I take the square root, that is not a perfect square, so therefore I also had another option of 4 and 4. I'd like you to pause it here and come up with one of your own and see if you got one similar to my next example, okay? All right, guys, so you should have came up with a final example. I'm going to just try to make up one and see if I get a correct answer. So if I have 3 and 6, let's see if that works. So this would be 3 squared plus 6 squared equals c squared. So this would be 9 plus 36, and that's going to equal 45. If I took the square root of both sides, that would give me a radical number that is less than radical 49, which is 7. So therefore, 3 and 6 also work. Okay? All right, so let's go ahead now and look at the last one. And what it's saying is the size of a rectangular TV is determined by measuring the length in inches of the diagonal of the screen from bottom left corner to top right corner. A television you manufacture doubles the length and doubles the width of one of the televisions and advertises that the new TVs doubled the size of the original, using the diagonal-based definition of TV. Is the manufacturer right? Draw a diagram. So what this guy is saying is I have this TV, right? And how they measure the distance of a TV, or how big is in inches, they measure diagonal from these two corners. So what it's saying is this is my A value, this is B value, this is C squared. Or excuse me, this is C. They determine the length of your television by C. So TV length. So it's saying if I double this, will this also be doubled to 2c? So let's go ahead and look if this is true. So this would look like then a squared plus b squared equals c squared. I'm going to double a, so this would be 2a parentheses squared plus 2b parentheses squared. Let's see what that would equal. So remember, this gets distributed to both terms. So this would then be 2 to the second power times a to the second power plus 2 to the second power plus times b to the second power. That would give me 4a squared plus 4b squared equals c squared. So therefore, if I factor out of 4, it'd be 4 parentheses a squared plus b squared. And we know a squared plus b squared equals c squared. So that would give me 4c squared. And if I factored out a 2, that would give me my answer of 2c parentheses squared.